Hello, and welcome back to our masterclass on sedimentary rocks. In our last episode, we saw how sediments get transported. Today, we'll explore what happens when that journey ends, deposition. Imagine a river full of energy carrying sand, silt, and clay. As the river slows down, it can no longer hold onto its cargo. The heaviest particles, like gravel and sand, drop first, often in the river channel itself. The finest silts and clays are carried further, settling on the floodplains during a flood. This is deposition in action. It's all about a decrease in transport energy. This simple principle creates an incredible variety of landscapes, or as geologists call them, depositional environments. In a desert, the wind loses energy and drops sand, building majestic dunes. At the coast, a river meets the ocean, its energy dissipates and it deposits its sediment load, forming a delta that builds out into the sea. Far offshore, in the deep, quiet marine environment, the energy is very low. Here, the tiniest particles, like fine clay and the microscopic shells of plankton, slowly rain down, accumulating over millions of years. Each of these environments leaves a unique fingerprint in the rock record. A desert sandstone looks very different from a deep sea shale. By studying a rock's characteristics, its grain size, the types of fossils it contains, and its internal structures, we can identify its original depositional environment. It's like being a detective, piecing together clues to reconstruct ancient landscapes. We can identify ancient rivers, deserts, and oceans that disappeared millions of years ago. But these environments are not static. They shift and change over time. Sea levels rise and fall, climates get wetter or drier, and tectonic forces uplift mountains or create basins. When sea level rises, a sandy beach environment might be replaced by a deeper, muddy offshore environment. This change is preserved in the rock layers. We see a vertical succession, with sandstone at the bottom overlain by mudstone. This is what we call a facies succession. By studying these vertical sequences, we can read the story of how an entire basin evolved. We can map the advance and retreat of ancient shorelines and understand the dynamic history of our planet, all written in the layers of sedimentary rock. It's a fascinating narrative of change, preserved for us to decipher. Thank you for joining me for this episode. We've covered how sediments are deposited and how their environments create the rock record. In our next episode, we will explore what happens after deposition, the process of turning loose sediment into solid rock. Be sure to subscribe so you don't miss it. See you next time.